Welcome to mathematics classes. Today we'll see some critical questions from integration. This is mainly JEE PYQs. With this 4 or 5 standard ways of solving integration we'll learn. Okay, so let's get into it. Yeah. The first one is it's an interesting one. If integration of sine to the power of 3 by 2x plus cos to the power of 3 by 2x divided by square root of sine cube x cos cube x into sin x minus a dx equal to a times square root of cos a tan x minus sin a plus b times square root of cos a minus sin a cot x plus c. C is the integration constant. Then what is the value of AB? Basically, we need to solve this integration, right? That's all in this form. Okay, answer should be in this form. So, whatever a part of this integration term you take it as the temporary variable t, you can't really cancel the terms and then make it simple. Okay, it's not possible that way. What we have to do is actually split the fraction and then solve the integration. Okay, let me show how it can be done. This is very interesting. So take the denominator first. Denominator, write it in a way so that you cancel many of the terms when you take the temporary variable. Correct? So square root of sine cube x cos cube x into sin x minus a. If I expand sin x minus a, this is what it is. Okay. Now I can either take sin x as common or take cos x as common. Correct? So if I take sin x common, okay, this is what cos x common, this is what it will be. Sin cube x as is cos to the power of 4x into tan x cos a minus sin a. Okay. Now I can also take sin x also common. Okay. So for this one, this is what it will become, right? If I take these two terms out of square root, it will become sin to the power of 3 by 2x cos square x and square root of tan x cos a minus sin a. Now if you see, if I substitute this for this part, if I split fraction, okay, I can actually cancel this one and I am left with only denominator 1 by denominator, this value. Correct? So same expression, if I take sin x common, it will become sin square x into cos to the power of 3 by 2x square root of cos a minus cot x sin a. Okay, now this I can replace with this value. Okay, so let's do how to do this. This is very simple. So now integration I'm splitting into two partial fractions, sum of two partial fractions like this. Okay, now in the first part, first integration I will solve using this value. Denominator I'll replace with this. Second integration I'll solve by taking denominator as this value. Okay, so in this case, this is what it will become. I will be left with secant square x divided by square root of, because 1 by cos square, right? I will be left with 1 by cos square x. 1 by cos square x is secant square x. Secant square x dx divided by square root of tan x cos a minus sin a. Cos a minus tan a. We know that cos a and sin a are constants. Okay, so if I take tan x as t here, secant square x dx will be dt. So that's so simple. Plus cosecant square x dx divided by cos a minus cot x sin a. Okay, for the second part. Now here I will take tan x or this whole thing as t. Here I will take this whole thing as t. Correct? So in the first case, let tan x cos a minus sin a equal to t and cos a minus cot x sin a is some y. Okay? So this will become a secant square x equal to cos a secant square x dx equal to dt and sin a cosecant square x dx equal to dy. Right? Now you replace it. The integration is very simple. Integration of dt by cos a square root of t plus integration of dy by sin a square root of y. Okay. Now we know what is the integration value of this one. This is nothing but 2 times square root of t by cos a plus 2 times square root of y by sin a plus constant term. Okay. If I replace t and y back, this is what it will become. Okay. Okay, and 1 by cos a I wrote it as secant a, 1 by sin a I wrote it as cosecant a. Okay, now you compare this with given expression here. Okay, which is same exactly. A is 2 secant a, B is 2 cosecant a. Correct. So A into B is nothing but 4 by cos a sin a, cos a and sin a, which is nothing but either I can write it as 8 times sin 2a or I can leave it like that. Depending on the multiple choice, you can choose which one is correct. Okay, this is the answer. Next. Yeah. For x belongs to minus pi by 2, if y of x equal to integration of cosecant x plus sin x divided by cosecant x secant x plus tan x sin square x dx and limit of x tends to pi by 2 minus y of x equal to 0, then what is the value of y pi by 4? Basically, this is given to find out the constant value. That's all. Okay, so let's see first solve the integration and then take it to the next. Okay, so this is what it is given. Let's simplify this one. Okay, if I replace cosecant with 1 by sine, this will become 1 plus sine square x by sine x in the numerator. And then if I replace both the cosecant secant by with 1 by sine x, 1 by cos x, this is what it will become. 1 plus sine to the power of 4x divided by sine x cos x, which is simplified. 1 plus sine square x into cos x divided by 1 plus sine to the power of 4x. Okay, now if I take, let's say, sine x as t, then cos x dx is dt. So it will be simple integration, correct? So y of x equal to this value. And then if I take sine x as t, cos x dx is dt. Then you should know this standard one. Actually, y of x, if it is in the form of integration of 1 plus t square by 1 plus 2 to the power of 4 dt, this is a standard integration. You should remember. But if you don't remember, this is how we will solve it. Let's go there and check. Okay. So how to solve this integration of 1 plus t square by 1 plus 2 to the power of 4 dt, correct? So this is what it is. 1 plus t to the power of 4, I can write it as t square plus square root of 2 plus 1 into t square minus square root of t square root of 2t plus 1. Okay. Now my fraction will become like this. Now I will apply partial fraction method basically. Okay, which is equal to a by denominator partial denominator, b by plus b by partial denominator. Second part. Okay. Now you solve this equation for a and b. You will get a plus b equal to 1 because it is t square coefficient is 1. Then minus a plus b is 0. Okay, so with this I can solve it. B is half, a is half. So my integration is nothing but half of integration of 1 by t square plus square root of t plus 1 plus 1 by t square minus square root of 2t plus 1 dt. Okay, now this is simple. This I will write it in the form of a plus b whole square and then solve it, right? So half into integration of 1 by t plus 1 by square root of 2 whole square plus 1 by 2. Similarly, second part. Now this is nothing but sine inverse. We know it. Sorry, tan inverse. Okay, so 1 by 2, 1 by a is 1 by square root of 2. So 1 by a tan inverse of x by a. This is my x by a. Okay, similarly here, simplify it. This is what you will get. Okay, so either you can say this is the answer, or if you understand inverse trigonometric functions, you can add these two are angles basically, right? This will become 1 by square root of 2 tan inverse of square root of 2t divided by 1 minus t square plus constant. Okay, so this is what we will use in the question given. Okay, so let's go back to the question, main question. Okay, so this is the standard integration which I said, but in case you don't remember, I showed you the how to solve it. Okay, so 1 by square root of 2 tan inverse of square root of 2t divided by 1 minus t square plus constant. Okay, now you substitute the t value. This is what it is. Okay, now it is information given here. Limit extends to pi by 2 minus y of x equal to 0. Correct. Now you just substitute. This is a limit pi by 2 minus, if I substitute, obviously sine pi by 2, this is 1. But this will become, this is also 1. So 1 minus 1 is 0. So this will become tan inverse of infinity. Okay. Tan inverse of infinity is, we know, pi by 2. Correct. Tan inverse of infinity is pi by 2. So this is pi by 2 root 2 plus k equal to 0, which means k is constant is nothing but minus pi by 2 root 2. Once you get the constant value, y of pi by 4 is very simple. So y of pi by 4 is 1 by square root of 2 tan inverse of square root of 2 into 1 by square root of 2 divided by 1 minus 1 by square root of 2 whole square. Simplify it basically, and this is the constant term minus pi by 2 root 2. Okay, simplify it. You get the answer, that is 1 by square root of 2 into tan inverse 2 minus pi by 2. Okay, it looks complicated, but this is the option, right option from the choices. Okay, this is the answer. Okay, next. Okay, I made it minus because this is an angle pi by 2. This is also angle. Okay, so we know that tan inverse of this one and minus pi by 2, if you take, you get actually cot inverse, and cot inverse, if I translate back to tan inverse, it will become minus. Okay, so that's what I did here. Okay, next. For alpha, beta, gamma and theta belongs to natural numbers, if integration of x by e whole to the power of 2x plus e by x whole to the power of 2x into log x dx equal to 1 by alpha x by e to the power of beta x minus 1 by gamma e by x to the power of theta x plus constant. Okay, where e is nothing but this expression we know already. Then alpha plus 2 beta plus 3 gamma minus 4 theta is how much? Okay, yeah, this is the interesting question. We know that this we can solve using logarithms, right? So let's do it independently actually. Okay, so first thing is you take u as x by e whole to the power of 2x. So log u is nothing but 2x into log to the log x by e. Okay, which means 2x into log x minus 1. Correct? This is log x minus log e. Log e is 1. Okay, now if I differentiate this 1 by u du by dx equal to 2 times this is x into this expression, right? So first I differentiated x, so 2 into log x minus 1 plus 2x by log x minus 1 differentiation is 1 by x. Okay, so which is nothing but if I simplify, this is 2 log x. Okay, so du by dx is nothing but x by e to the power of 2x into 2 log x. Okay, note down this one and then take the second part. Okay, and integration of this one, if I take this first half, basically integration of x by e 2x log x dx is nothing but, okay, correct, you see here, no, this integration is nothing but this basically, correct. Reverse, if I do du by dx, if I do apply reverse, basically it is u, correct. If I apply integration here, this is u by 2. Okay, so this first half, basically integration first half. Okay, leave this one, this is second half, we'll do again. Okay, so this is u by 2, which is equal to 1 by 2 into x by e to the power of 2x plus constant. Okay, similarly take the second part. Okay, v equal to e by x to the power of 2x, log v is 2x log e by x, which is nothing but 2x times 1 minus log x. Okay, which is exactly opposite to this actually, right? So you will actually get negative of this value, that's it. Right, minus 2 log x is the dv by 1 by v dv by dx. If you differentiate, this is what you will get. So your dv by dx is nothing but e by x into e by x to the power of 2x into minus 2 log x. Now you integrate this, basically second part is same again, correct. If you integrate the second part, you get minus dv by minus v by 2. Okay, this is minus v by 2, which is this value. Now we have partial of both actually, it's just a matter of summing up. So integration of this whole integration is nothing but sum of these two integrations, which is this value here, which we derived just now. Okay, and constant will become some new constant, that's all. Now check the form. Okay, it is in the form of 1 by alpha x by e whole to the power of 2x. So my alpha is 2, beta is 2, gamma is 2, and theta also 2. All are 2 basically, correct. So my alpha plus 2 beta plus 3 gamma minus 4 theta is nothing but 4. That's the answer. Okay, next. If I of x equal to integration of e to the power of sine square x into cos x sin 2x minus sin x dx, and I of 0 equal to 1, then what is the value of I of pi by 3? Okay, so whenever you see e to the power of something in integration, we have one formula which we generally use is integration of e to the power of x into f dash x plus f of x dx is nothing but e to the power of x into f of x. Okay, this is the second one, which is very important. Remember this one. This is also very easy actually to remember. Okay, so let's see how to solve this problem. Okay, so first thing is this is a JEE trick, you should remember. Okay, because deriving this is very difficult. Okay, otherwise. So e to the power of f of x, if this is in this form, e to the power of integration of e to the power of f of x into f dash x into cos x minus sin x dx, which is equal to cos x into e to the power of f of x plus k. Okay, so what are the things which we should remember? Thing is, it is e to the power of some expression, same thing here. Okay, then in the this should be multiplied with f dash x into cos x. Okay, so sin square x differentiation is 2 sin x cos x, which is sin 2x. So you have f dash x into cos x minus sin x. Okay, then this is nothing but cos x into e to the power of f of x plus constant. Okay, similarly, if let's say if sin and cos are exchanged, it will become sin x plus cos x. Then you may question how to remember this one. Okay, this is simple. Cos x differentiation is minus sin x. Sin x differentiation is cos x plus cos x. Correct? So this is how we should remember. And in this case, this will become sin x into e to the power of f of x plus constant. Okay, now how do you want to prove this? Okay, we can, derivation is difficult, but proving is very easy. You take this value and then just differentiate. Okay, so differentiation of cos x into e to the power of f of x by dx is nothing but cos x into e to the power of f of x into f dash x minus, okay, minus cos x into e to the power of f of x. Sorry, minus sin x into e to the power of f of x, not cos x, sin x. Okay, sorry, I made a mistake. This is sin x. Okay, sin x e to the power of, because we are differentiating cos x, right? So minus sin x e to the power of f of x. Now this is, if I take e to the power of f of x common, this is nothing but f dash x into cos x minus sin x, right? So this is what it is. Okay, differentiating, if I differentiate this, I am getting this value, which means if I integrate this, I'll get this value, correct? Now this problem looks very, very simple, correct? So we know that differentiation of sin square x by dx is nothing but 2 sin x cos x, which is sin 2x. So everything is set. It is in this form. So I of x equal to cos x into e to the power of cos x into e to the power of sin square x plus constant. Okay. Now substitute I of 0. I of 0 is nothing but it will become 1 plus k. Okay. Which means which is equal to 1, which is given. I of 0 is given as 1. So that means k is 0. Okay. Once we know that k is 0, I of pi by 3 is nothing but cos pi by 3 into e to the power of sin square pi by 3. That is 1 by 2 into e to the power of 3 by 4. This is the answer. Okay. Next. If I of x equal to integration of x square into x secant square x plus tan x divided by x tan x plus 1 whole square dx, and I of 0 equal to 0, then what is the value of I of pi by 4? Okay. So if you see, if I take x tan x plus 1 as my temporary variable t, then I get x secant square x plus tan x dx equal to dt. There is only extra term x square here, right? So you apply integration product rule, take x square as the f of x and rest of it as g of x, correct? That's how you should solve it. Okay, so applying integration product rule, f of x is x square, g of x equal to x secant square x plus tan x divided by x tan x plus 1 whole square. Okay, then I of x equal to, okay, uh, f of x into integration of g of x, that is here, minus integration of f dash x, x square differentiation is 2x, into integration of g of x dx. Okay, now all I need is this integration first, which is 2 times I have to use it here, right? So let's do this one. If I take denominator x tan x plus 1 as t, then x secant square x plus tan x dx is dt. So this integration I2 is nothing but 1 by integration of dt by t square, which is minus 1 by t, or minus 1 by x tan x plus 1. Okay, now if I replace this into the integration, first part is clear, first part is done. Second part is plus integration of 2x by x tan x plus 1. Okay, now second part also let's do it. Okay, let us simplify the second part. So tan x, you will write it as sin x by cos x. So this is what the integration is, 2 times integration of x cos x divided by x sin x plus cos x dx. Okay, so once you know this one, let's take x sin x plus cos x as t. So my dt is actually I will be left with only x cos x. Other two terms gets cancelled. Okay, so this is simple now. So I3 I will call it. I3 is 2 times integration of dt by t, which is nothing but 2 log t, or 2 log x sin x plus cos x, or you can take it as x sin x plus cos x square. If I replace all this, my integration I of x is nothing but minus x square by x tan x plus 1 plus 2 times log of x sin x plus cos x plus constant. Now substitute I of 0. Okay, if it is I of 0, all the terms become 0, which is, that means k is 0, constant term is 0. Then there is no constant basically. So I of pi by 4 is nothing but, okay, minus pi square by 16 into pi by 4. Tan pi by 4 is 1. So pi by 4 into 1 plus 2 log uh, pi plus 4 by 4 square root of 2. Okay, so this is the total integration value. Just to simplify it further, okay, log of, we can call it log of pi plus 4 whole square, because I am taking the 2 here to the square here. Okay, and then 4 square root of 2 will become 32. Okay, minus pi square by 4 times, because this will become, if I take LCM here, it will become pi plus 4 by 4. So 4 times pi plus 4. Okay, this is the final answer. Okay, hope you understand. You have to do integration multiple times. So just you need to be patient with the integration. But these are the good tricks to learn actually. Okay. Yeah, thank you. That's all. These are the 4 problems which I want to cover, and 2 concepts actually out of it, which are very important to note down. And other things are actually different methods of solving integration. We have the standard methods which you can see in my charts. Okay, but this is the standard method. Okay, thank you. Keep doing maths.